Hey guys, it's Margot at Lanterna here, back with another applications and interpretations maths video. So following on from the last video, we're going to be looking at matrix algebra part 2. So the last time we really covered the fundamental basis that we're going to be using and applying in this section. So we're going to be looking at the determinant of a matrix and the inverse of a matrix, and then finally how we can use an inverse of a matrix to solve systems of equations. So again, covering the final points of part 1.14 of the higher level syllabus. I really hope you enjoy this and find it useful. Good, okay then, looking at the determinant of a matrix. Not a huge amount to say here. This is a formula you get in your formula booklet, so make sure you know it's there. If we have a matrix, in this case a 2 by 2 matrix A, then the determinant of that matrix, which we denote as either det brackets of A or A inside straight brackets, is equal to elements A times D minus elements B times C. So let's just look at an example. Find the determinant of the matrix A, which is equal to this right here. Well, let's say A is equal to, well, A times D, this is my entry A, this is my entry D, so we have 2 times 7 minus entry B times entry C. So we have minus 4 times 1, which overall is 14 minus 4. So we find this is equal to 10. So just get used to using that equation. There's not too much to it. If you have to find the determinant of larger matrices or anything that goes beyond 2 by 2, you will use your calculator. The IB really only expects you to be able to solve these by hand for 2 times 2 matrices, nothing bigger than that. Okay, then finally the inverse of a matrix. Again, this is a formula given to you in your formula booklet. We have a matrix A, and its inverse is given by 1 over the determinant of A times, well, the elements A and D have switched since what they were before, and the elements B and C have been negated compared to what they were before. So that is simply the equation for the inverse of a matrix. So for example, let's look at the inverse of this matrix. It's the same as we saw before. So A to the minus 1 is equal to 1 over the determinant of A. Well, this is the same as the matrix in the previous slide, for which we found the determinant was 10. So if we switch our components A and D, we find 7 and 2 across the diagonal here, and we negate our other elements, so we get minus 4 and minus 1. So this is our answer for the inverse of matrix A. So what is the inverse of a matrix? Well, I like to think of it as the inverse matrix, A to the minus 1, undoes essentially what matrix A did. So what do we mean by that? Well, if we have a matrix A times X is equal to C, then we find that X is equal to the inverse matrix of A times by C. So just kind of get that idea in your head of an inverse matrix undoing what a matrix A did. So for example here, if we multiplied X by A, we got C. Well, what if we just want X? Well, we want to undo that multiplication by A. So we do that by undoing the multiplication by A and applying it to C. So we're going to see a really useful example of this, and that is when we're applying it to solving systems of equations. Just a reminder, what are systems of equations? Well, I've got an example on the slide right here. Find the values of X and Y such that they satisfy these two equations. Well, we know how to solve system of equations like this, right? We can do it using kind of what we've learned previously. For example, here we would rearrange X is equal to minus 2 minus Y, and we would substitute that then into the second equation, 5 times minus 2 minus y plus 7y is equal to 4. And we'd multiply this out to get minus 10 minus 5y plus 7y is equal to 4. So we find that 2y is equal to 14 and y is equal to 7. And if we substitute that back into our first equation, we find that x is equal to -2 minus 7, which is -9. So we know how to solve this, right? But, you know, we can get examples which are going to be a bit trickier than this one and which might not be so straightforward to solve like this. Either way, we should be aware of how we can use matrices to solve systems of equations. And I'm going to outline that method to you right here. First of all, we need to rewrite this set of equations in matrix form. So what we take is we take the coefficients of x and y to be the entries of this first matrix here. So we have coefficient 1 by x and 1 of y here. And then second equation, we have a coefficient of 5 and we have a coefficient of 7, which is reflected in that first matrix. And we have to multiply that by x and y to find our answers -2 and +4. So using that matrix multiplication that we looked at 2 slides, you can convince yourself that this matrix form is exactly the same as those 2 equations up there. Okay, well, let's look at this then. Well, let's name these matrices just to make it a little bit simpler to talk about. Let's say A is this first matrix, matrix X is equal to that second one, and C is our product. Then we can write this expression as AX is equal to C. And as we saw on the last slide for using inverse matrices, where an inverse matrix essentially undoes what our previous matrix did, we can find the solution for x, which is x and y. So let's have a look. How does that apply in this case? I'm going to solve it on the right hand side of this slide. Okay, so first of all, our task is to find the inverse matrix A to the -1. Okay. Well, A to the -1 is 1 over the determinant of A. So the determinant of A, if we remember, was A times D minus B times C. So in this case, we have 7 minus 5. And then what we have to do, remember, we switch our A and D and we negate our other components. So we get 7 minus 1 minus 5 and 1. So overall, this is going to be 1 over 2 times by 7 minus 1 minus 5 and 1. We're multiplying by a scalar here, right? A half is our scalar. So let's just write this as 1 matrix and multiply each component by 1 over 2. So we're going to get this right here. Okay, so we found our inverse matrix A minus 1. Now we need to multiply that by C to get our solution for matrix X, which is XY. So let's do A minus 1 times by C. Well, we have got this matrix here. Okay, well, let's just check, can we actually multiply these 2 matrices? Well, we have here a 2 by 2 matrix and we have here a 2 by 1 matrix, right? So we see, okay, these 2 numbers are equal, so we can multiply them, good to go ahead. And then our order of our matrix is going to be given by 2 by 1. So we're going to have 2 rows and 1 column. So if we work that out using our matrix multiplication, then our first entry is going to be minus 2 times 7 over 2 plus minus 1 over 2 times by 4. Our second row, well, we're multiplying the second row of A by our column C. So we get minus 5 over 2 times 2. So minus 2 times minus 5 over 2. And we're adding it to 1 over 2 times by 4. Overall, our answer to X is going to be equal to minus 7 minus 2. So we have minus 9. And then we have 5 plus 2, so 7. So X, our matrix X is equal to minus 9 minus 7. And remember, we said X was the matrix XY, so we see that little x is equal to minus 9 and y is equal to 7. So there we go, that is our answer to that problem. So I really hope you enjoyed that first online maths video. We're going to be back with plenty more, so I hope to see you back again. In the meantime, check out some of our other videos from other great tutors in subjects such as economics, geography, biology, ESS, you name it. I hope you enjoyed this video, and I hope to see you next time.